As the body ages, a silent yet potent force begins to shape the internal landscape: chronic low-grade inflammation, often termed inflammaging. This persistent inflammatory state doesn't just make aging more biologically costly, it undermines key cellular processes like autophagy, paving the way for diseases such as cancer. The intricate crosstalk between inflammation, autophagy, and tumorigenesis is especially relevant in older adults whose immune systems are both overactive in some ways and dangerously impaired in others. Understanding this complex triad is critical because the consequences of unchecked inflammation extend beyond joint pain or cardiovascular risk. It can suppress autophagy and create a microenvironment where cancer can thrive. Autophagy plays a protective, housekeeping role across the lifespan, clearing damaged proteins, dysfunctional mitochondria, and even precancerous cells. This mechanism prevents the buildup of cellular waste and genomic instability, hallmarks of aging and early tumor development. However, autophagy is highly sensitive to inflammatory signals. Pro-inflammatory cytokines like TNF-A, IL-1SZ, and IL-6, abundant in the elderly, can interfere with autophagy initiation and flux. This suppression reduces the cell's ability to neutralize oxidative stress and misfolded proteins, accelerating both senescence and oncogenic transformation. In essence, chronic inflammation disables one of the cell's key cancer prevention systems. The effect is cyclical and self-reinforcing. As autophagy is impaired, damaged mitochondria accumulate, leaking reactive oxygen species, ROS, that further amplify inflammatory signaling. This fuels even more cytokine production and recruits immune cells that, rather than clearing the problem, add to the local damage. Tissue integrity breaks down. Senescent cells, which are more abundant in the aging body, secrete their own cocktail of inflammatory signals, the senescence-associated secretory phenotype, or SASP, further inflaming the surrounding environment and driving malignant changes in neighboring cells. In this inflammatory ecosystem, tumors find fertile ground. The constant immune activity creates DNA damage, encourages cell proliferation, and degrades the barriers that normally restrain aberrant growth. Tumorigenesis in the elderly is thus not just a matter of genetic mutations building up over time. It is actively shaped by a deteriorating systemic environment in which autophagy is suppressed and inflammation is relentless. Yet there is a positive outlook here. Unlike some genetic predispositions, inflammaging is modifiable. Controlling inflammation in older adults can help restore autophagic activity and reduce cancer risk. Lifestyle strategies like intermittent fasting, exercise, and calorie moderation are known to reduce systemic inflammation and stimulate autophagy. These interventions not only improve metabolic health, but also reinforce cellular recycling and immune surveillance. Pharmacologic interventions are under increasing scrutiny as well. Metformin, originally a diabetes drug, has shown anti-inflammatory and autophagy-promoting effects and is now being studied for cancer prevention in elderly populations. Natural compounds such as curcumin and quercetin, which possess anti-inflammatory properties, may also help restore autophagy and limit cellular transformation, though clinical evidence remains early stage. Nonetheless, the interplay is nuanced. Not all inflammation is harmful. Acute, short-term inflammation helps clear infections and stimulates autophagy. It's the chronic, unresolved kind, widespread in the elderly due to immune dysregulation, obesity, and metabolic dysfunction, that's particularly dangerous. Likewise, autophagy itself can support cancer cell survival in established tumors. So while reactivating it may help in prevention, timing and context matter greatly when designing anti-aging or anti-cancer interventions. A warning must also be issued against excessive or misdirected anti-inflammatory use. Long-term reliance on NSAIDs or corticosteroids to control age-related inflammation can impair immune function or disrupt necessary stress responses. Blunting inflammation indiscriminately can backfire, as some degree of immune activation is essential for tumor surveillance and pathogen defense. A more precise approach is needed, one that restores balance rather than simply shutting down one part of the system. In sum, the elderly body often walks a fine line between protective repair and destructive inflammation. When autophagy and immune regulation are intact, aging progresses with resilience and lower cancer risk. But when inflammation becomes chronic and autophagy is silenced, the balance tips, creating a pro-tumorigenic environment that thrives on cellular decay. Restoring that balance through targeted interventions holds great promise. Aging care should increasingly focus not just on treating disease after it appears, but on managing the internal ecosystem, reducing inflammation, reactivating autophagy, and strengthening the body's natural defenses against cancer before it takes root.